Okay, sorry about that. I was getting a phone call. All right, so here's where we are. We've got the numerator as negative a squared plus b squared, and the denominator minus ab times a minus b. So now I want to see if we can factor it all. The bottom's already factored, the numerator. Now this looks like we can't factor it. We've got a square and a square in addition, but notice if we rearrange this slightly, if you rearrange the numerator slightly, we could have b squared minus a squared. And this is, hopefully remember, the difference of two squares, which we can factor as b plus a, b minus a. So let's put that in our numerator. So I've got b plus a, b minus a, over negative ab, a minus b. All right, I'm just going to erase this top thing so that way we're not confused. All right, now we look to cancel. All right, don't have any b plus a down here at all, so that looks like it's set. Now notice I've got a b minus a and an a minus b. These are opposites, right? These are opposites. So if I take a negative out of this, I can change this to be a minus b, the negative of that, or in a sense negative 1 times that. So I'm going to cancel this and rewrite it as a minus b times negative 1. But now I have two things that cancel down here. I've got the negative and the negative that can cancel, and the a minus b and a minus b. Let's look at that one more time. I changed the b minus a to its opposite, a minus b, and pulled a negative out. The negatives cancel, and the a minus b's cancel. So I'm left with b plus a over ab. There's your final answer for 47. Okay, last one, we're going to look at 51. All right, so I've got x minus 11 over x squared minus 9. And subtracting from that, x minus 7, x squared minus 3x. Okay, so let's look and see if we can do some factoring down in the denominator to find that least common denominator. This is the difference of two squares, so that factors to be x minus 3 and x plus 3. Over here I have a common factor, binomial factor of x, so this is x times x minus 3. All right, so my least common denominator is going to have an x minus 3, an x plus 3, and an x. So let's go ahead and write my denominator. X minus 3, x plus 3, and there's the x. Okay, so to go from here to this, I need to multiply by the x. That's the only thing I don't have. So I need to multiply this fraction, or this numerator, by that x. The whole thing. So x times x is x squared. X times the negative 11 is minus 11x. If you wrote it this way, that's fine too. Just make sure you change it in the end. Okay, minus, there's my subtraction. Now to go from here to here, I've got the x's. Here's the x's. I've got the x minus 3. I'm missing this x plus 3. So I need to multiply the numerator by the x plus 3. Now be careful. I need to subtract this whole thing. So after I FOIL this, I need to subtract it. So I'm going to put these in brackets so I remember that it's subtracting the whole thing. All right, so let's go ahead and do the FOIL there. I've got x times x is x squared. All right. I've got my inner term and outer term. My outer term is 3x. My inner term is a minus 7x. My last term is the minus 21. Now remember, I'm subtracting that whole thing, so when I put it back in my fraction, x squared minus 11x minus the x squared minus the 3x minus the negative, so plus 7x plus 21. x, x minus 3, x plus 3. All right, so let's go ahead and find some like terms. I've got an x squared and a negative x squared. So those are going to cancel. I've got a negative 11x, a negative 3x, so that's negative 14x, and a positive 7x, so that's going to give me a negative 7x. And then I just have this positive 21 at the end. It's going to be over x times x minus 3, x plus 3. Last thing I'm going to do is see, can I do any sort of factoring? Notice in the numerator, I could pull out this negative 7. So I'm going to divide everything by negative 7. So I've got negative 7 times positive x. If I divide 21 by negative 7, it gives me negative 3. Negative 3 times negative 7 would be positive 21. X, x minus 3, x plus 3. Now notice I have the x minus 3 on both the top and the bottom, so I'm left with just negative 7 over x times x plus 3.